Children, let me take up some of the numerical on the unit electrochemistry. The first one, how much charge is required for the following reductions? Let me take up the number one, 1 mole of Al3 plus ions to aluminium. Look at here, children, Al3 plus is reduced to Al. Look at here, I need 3 moles of electrons. Children, that means N is equal to 3 moles of electron, and you know the formula, Q is equal to N into F. Is it not? Look at here, N is equal to what? 3, and Faraday value, you know that, 96,500 coulombs. Children, if you simplify, you are going to get 2,89,500. Let me write 2,89,500 coulombs. So this is the answer for the first one. Hope you got it. Children, let me take up the second one. Look at here, reduction of 1 mole of Cu2 plus ions to Cu. Now look at here, Cu2 plus ions reduced to Cu. Now how many moles of electrons are required here? 2 moles of electrons are required. Is it not? Now N is equal to how much here? N is equal to 2 moles of electrons. Children, now I'm going to put Q is equal to N into F. 2 into 96,500 coulombs. Children, if you simplify, you are going to get 1,93,500 coulombs. Let me go for the next one. Look at here, 1 mole of MnO4 minus to Mn2 plus ion. First, we need to find out the oxidation state of Mn in this MnO4 minus ion. Look at here, MnO4 minus ion is equal to -1. This you already learned in the 11th class. Okay, let Mn oxidation state as X plus, oxygen, how many atoms are there? 4 into oxidation state is equal to -2, that is equal to -1. X minus 8 is equal to -1. So X is equal to +7. Hope you got it. Now look at here, the oxidation state of Mn in MnO4 minus is +7. Now I need to convert that into Mn2 plus. Remember, the decrease in oxidation number, that means what? A reduction. Now look at here, from 7 it is decreasing to 2. That means I need to add 5 moles of electrons. Children, in that case, now N is equal to how much here? N is equal to 5 moles of electron, and you know the formula, Q is equal to N into F. N is what here? 5 into 96,500 coulombs. Children, if you simplify, you are going to get 4,82,500 coulombs. So this is what Q. So this is how you need to solve a numerical if they ask on number of moles of electrons and charge required for the reduction of a particular amount of ions. Let me go for the next numerical. Children, let me take up the second numerical for you. How many coulombs of charge required to produce 1 mole of oxygen from water? Children, look at here. By the electrolysis of 2 moles of water, you are going to get 2H2 plus O2. That means 1 mole of oxygen you are going to get. Is it not? Let me simplify this. 2 moles of water on electrolysis, you are going to get 4H plus. Is it not? Plus 4 electrons. Now this is nothing but together 2H2 plus oxygen. Remember, for the production of 1 mole of oxygen, you require 4 moles of electrons. Look at here, how do I write? So N is equal to 4 moles of electrons, and you know the formula, Q is equal to N into F. Is it not? Now N value is how much here? Is 4. That is 4 into 96,500 coulombs. Is it not? Now I simplify that, you are going to get 3,86,500 coulombs. So this is what Q. That means you require 3,86,500 coulombs to produce 1 mole of oxygen from water. Children, very simple numerical. If you solve this, you are going to get 1 mark. It's very important not only for CBSE board examination but also important in the case of competitive examination. Children, let me take up a third numerical for you. How many coulombs are required for 50 grams of aluminium when the electrode reaction is Al3 plus 3 electron e raised to Al, given atomic mass of aluminum is equal to 27 unified mass. Let me write, look at here, Al3 plus 3 moles of electron, you are going to get Al. Children, in this case, number of moles of electrons for the reduction of 1 mole of aluminium ions to aluminium is equal to Q is equal to N into F. N is what here? 3 Faraday. That means you require 3 Faraday of charges for the reduction of 1 mole of aluminium ions to aluminium. Children, for reduction of 27 grams of aluminium ion. Why? Because atomic mass of aluminium is equal to 27. You require how many? You require 3 Faraday of charges. Is it not? Now let me go for the reduction of 50 grams of aluminium ions. How much of charge is required? You go for the cross multiplication. Look at here. You're going to get 50 into 3 upon 27. That means, look at here, you are going to get 5.5 Faraday of charges for the reduction of 50 grams of aluminium ion to respect to aluminium. Children, let me go for one more simple numerical. How many coulombs of electricity is required for oxidation of 1 mole of FeO to Fe2O3? Children, first let us find out oxidation number or the state of Fe in FeO and Fe in case of Fe2O3. For that, you know how to find out the oxidation number of a particular compound. As a neutral compound, I'll take it as 0. Now X I need to find out as Fe plus oxidation state of oxygen is -2, that is equal to 0, and X is equal to +2. So this is what oxidation state of Fe in FeO. This is +2. Let me go for Fe2O3. Look at here, Fe2O3 is a neutral compound. I go for 0. Now I need to find out what? I need to find out Fe's oxidation state in this compound. So let me go for 2x plus, so 3 atoms of oxygen into -2, that is equal to 0. Now 2x is equal to -2 into 3, 6 plus 6. X is equal to +3. Children, in this case the oxidation state is +3. What are they asking here? Children, how much of coulombs of electricity is required for the oxidation of 1 mole of FeO to Fe2O3? That means, look at here, they are asking 1 mole of Fe2 plus 2 Fe3 plus. Look at here, 2 plus as becoming 3 plus. That means increase in oxidation state is nothing but what? Oxidation. Look at here, in that case I need to remove 1 electron here. That means N is equal to 1 mole of electrons. That means 1 mole of electrons are required for the conversion of 1 mole of FeO into Fe2O3. Hope you got it. Now you know the formula. Q is equal to N into F. Is it not? What is N here? Number of moles of electrons, that is 1. And Faraday value, you know that, 96,500 96,500 coulombs. Now that is equal to 96,500 coulombs. Children, 96,500 coulombs of electricity is required for the oxidation of 1 mole of Fe2 plus into Fe3 plus ions, or 1 mole of Fe2O3. This is how you need to solve the problem. That is why before going to take up the problem, you should read the numerical for 2 times and then only you have to go for solving the problem. Children, let me go for one more simple numerical. How many coulombs of electricity is required for 1 mole of fluorine 2 fluoride ions? Look at here. For the reduction of 1 fluorine atom to fluoride ion, you require 1 mole of electrons. 1 mole of electrons. Now, for fluorine molecule to get converted into 2 fluoride ions, you can guess you require 2 moles of electrons. Is it not? Now, N is equal to 2 moles of electrons, and you know the expression Q is equal to N into F. N is what here? 2. 96,500 coulombs. And simplify, you are going to get 1,93,000 coulombs required for the conversion of 1 mole of fluorine to 2 fluoride minus ions. Children, let me take up the next numerical for you, which has been asked in the board examination. Again, it's a simple numerical, you can easily solve. How much electricity in terms of Faraday required to produce 20 grams of calcium from molten calcium chloride? B. 40 grams of aluminium from aluminium oxide. Given atomic mass of calcium is equal to 40 unified mass and aluminium is equal to 27 unified mass. Let me take up the first part. Children, in the case of calcium chloride, calcium oxidation state is a +2, is it not? Look at here. For the reduction of 1 moles of calcium ions into calcium, you require 2 moles of electrons. That means N is equal to 2 moles of electrons. And you know the formula, Q is equal to N into F, that is equal to 2 Faradays. For the reduction of 1 moles of calcium, you require 2 Faradays of electricity. Now children, for 40 grams of calcium chloride to calcium, you require 2 Faraday. Then for 20 grams of calcium chloride to calcium, how much? Now you can go for the cross multiplication, 20 into 2 upon 40. Now you are going to get 1 Faraday. Children, 1 Faraday of electricity is required for the reduction of 20 grams of calcium chloride into calcium. Hope you got it. Let me go for the other side. Children, in the B part, aluminium's oxidation state is a +3. Now look at here, Al 3 plus has to reduce to Al. For this I need 3 moles of electrons. Children, for 2 Al3 plus moles ions, you require 6 moles of electrons to reduce it to 2Al. In that case, look at here, N is equal to 6 moles of electrons. Q is equal to N into F, 6 Faradays. Hope you got it. Children, for 54, children, atomic mass of aluminum is equal to 27. How many atoms are there? 2 atoms. 2 into 27, 54. 54 grams of Al2O3 to Al, you require 6 Faraday. In that case, for 40 grams of aluminium oxide to aluminium, how much? Children, you need to go for cross multiplication. In that case, 40 into 6 upon 54, you are going to get 4.4 Faradays of electricity is required to convert 40 grams of aluminium oxide to aluminium. Children, let me go for the next numerical. How many moles of mercury will be produced by the electrolysis of 1 molar mercuric nitrate with a current of 2 amperes for 3 hours? Given molar mass of mercuric nitrate is equal to 200.6 gram per mole. Children, let me write the given data for you. I is given, is it not? Electric current 2 amperes. T is given, how much? 3 hours. I need to convert this into seconds. What do? Look at here, 60 minutes into 60 seconds. Now I am going to get 3600. Is it not? I multiply by 3600 seconds. Now in that case, children, we need to find out Q. Hope you understand that. Now you know the expression Q is equal to I into T. I is how much here? 2 ampere. 3 into 3600. Children, you are going to get 21,600 coulombs of charge. Let me go for the second part. Look at here. In the case of mercuric nitrate, the oxidation state of mercury is +2, Hg2 plus. For reduction of 1 mole of mercuric ion into mercury, you require 2 moles of electrons. Is it not? That means 2 Faradays of electricity or the charges are required for the deposition of 1 mole of mercury. In that case, look at your children, Q is equal to N into F. Is it not? Now what do? Look at here, N I need to find out. Is it not? F Q. Q is how much here? 21,600 upon 2 into Faraday. Faraday how much here? 96,500. If you simplify, you are going to get 0.111 moles. So this is what the answer you are looking from this numerical. Children, let me take up a numerical on molar conductivity, which is very important for the examination. The conductivity of 0.20 molar solution of potassium chloride at 298 Kelvin is 0.0248 Siemens per centimeter. Calculate molar conductivity. Simple numerical, children. Let me write down the given data. Look at here. Concentration of the potassium chloride solution is given, that is C is equal to how much? 0.20 molar. Then what else is given here? Conductivity is given, how much? Look at here, K is given, K is equal to 0.0248 Siemens per centimeter. What are they asking? They are asking molar conductivity. Children, you have learnt the relationship between molar conductivity and conductivity, is it not? Look at here, molar conductivity is equal to K into 1000 upon concentration. And one more expression you learnt, molar conductivity is equal to K upon 1000 into C. Children, while discussing about this molar conductivity, I told if conductivity is given in terms of Siemens per centimeter, then I should go for this expression. If the conductivity is given in terms of Siemens per meter, then I should go for this expression. Children, look at here, conductivity is given in terms of Siemens per centimeter, that is why I'll go for this expression. Hope you understand that. Now let me substitute the value. K is how much here? K is 0.0248 into 1000 upon C is how much here? 0.20. Children, if you simplify, you are going to get 124 Siemens centimeter square per mole. This is molar conductivity of potassium chloride solution with conductivity 0.0248 and the concentration 0.20 molarity. Let me take up one more numerical on the same molar conductivity. Children, let me take up one more numerical on molar conductivity. Let me read out. The molar conductivity of 1.5 molar solution of an electrolyte is found to be 138.9 Siemens centimeter square per mole. Calculate the conductivity. Again, it is very simple, children. Let me solve this numerical for you. Given data. Look at here. C is given. Concentration. How much? 1.5 molar concentration. What else is given? Molar conductivity of this solution is given. How much? There is lambda m is equal to how much? 138.9 Siemens centimeter square per mole. And what are you supposed to calculate? Conductivity. Children, look at here. Lambda m is given in terms of centimeter. Is it not? In that case, lambda m is equal to K into 1000 upon C. Children, what is K here? K we need to find out. K. So C into lambda m upon 1000. What is C? 1.5 molar solution. Lambda m is given here 138.9 Siemens centimeter square per mole. So 1000. Children, if you simplify, you are going to get 0.2083 Siemens per centimeter. Children, this is what conductivity, otherwise called specific conductance or kappa. Children, let me go for one more numerical on molar conductivity. Specific conductance of a 0.1 molar NaCl solution at 298 Kelvin is 1.1 Siemens per meter. Calculate molar conductivity, that is lambda m. Children, let us write the given data. Now, specific conductance is nothing but conductivity, is it not? K is equal to how much? It is 1.1 Siemens per meter. Whereas C is given how much? 0.1 molar NaCl solution. What are they asking? They are asking to find out molar conductivity. Children, look at here. In the conductivity, the unit is Siemens per meter. So that is why you should be very careful while choosing the expression for finding the molar conductivity. Lambda m is equal to K upon 1000 into C. What are they asking? To find out lambda m. Look at here. K is how much here? 1.1 Siemens per meter. 1000 into C is how much here? 0.1. Children, to simplify, we are going to get 0.11 Siemens meter square per mole. So this is what lambda m, otherwise molar conductivity. Children, let us go ahead with one more numerical of a different type. When a certain conductance cell was filled with 0.20 mole per dm cube aqueous solution of KCl, its conductivity was 2.78 into 10 to the power of minus 3 Siemens per centimeter, had a resistance of 82.5 ohms at 300 Kelvin. Calculate the cell constant. Children, let me solve this numerical for you. Let me write whatever the given data. So C is given, that is a 0.20 mole per dm cube. Alright. Conductivity is given, K is equal to how much? 2.78 into 10 to the power minus 3 Siemens per centimeter, is it not? What else is given? Resistance is given. Resistance is equal to 82.5 ohms. Children, what are they asking? They are asking to calculate cell constant. Children, there is an expression between cell constant and conductance and conductivity. Let me write. Look at here. Cell constant, this you need to remember, is equal to conductivity upon conductance. What is that? Conductance. Children, you are aware that conductance C is inversely proportional to resistance. You have already learnt about conductance and resistance, is it not? In that case, look at here. Cell constant is equal to conductivity upon conductance. What I take? 1 by R, resistance. In that case, look at here. Cell constant is equal to conductivity K into R, resistance. This R will go to the numerator, is it not? Now, what is the conductivity here? Look at here. There is a 2.78 into 10 to the power of minus 3 Siemens per centimeter. Resistance is given how much? It is 82.5 ohms. Now, if you simplify, you are going to get 0.229 per centimeter. So this is what cell constant value for the above numerical. Children, let me take up one more numerical of a different type. The resistance of a 0.5 molar solution of an electrolyte is enclosed between two electrodes 1.5 centimeter apart and having an area of 2 centimeter square was found to be 30 ohms. Calculate molar conductivity. Children, let me list down the data given in the numerical. Look at here. Concentration is given 0.5 molarity. And L is given, is it not? Distance of separation between the two electrodes is given 1.5 centimeter. And area is given how much? 2 centimeter square. And resistance is given how much? 30 ohms. What are they asking? Children, they are asking molar conductivity, lambda m. Children, in order to find out molar conductivity, you need to find out conductivity first. Let me solve the numerical. Children, while discussing about conductance and conductivity, I told, resistance is directly proportional to distance of separation between the two electrodes and resistance is inversely proportional to area of the electrode. Now in that case, look at here, R is directly proportional to L by A, is it not? I remove this proportionality sign. R is equal to rho into L by A, where rho is what? Resistivity, is it not? Now rho is equal to R into A upon L. Children, remember, rho is nothing but resistivity or specific resistance, which is inverse of conductivity. Children, always remember, rho is inverse of conductivity. In that case, let me write the expression. Look at here. K is equal to L upon R into A. Is it not? Now length is given how much? 1.5 centimeter apart. Resistance is given 30 ohms and area of cross section is given how much? 2. Children, if you simplify, you are going to get a 0.25 Siemens per centimeter. This is what? Conductivity. Children, once you find out conductivity, now I can go for finding out molar conductivity. Look at here, in the expression we have centimeter. That means molar conductivity lambda m is equal to K into 1000 upon C. Now what is K here? K is equal to how much? 0.25 into 1000 upon C is how much? C is 0.5. 0.5. Children, if you simplify, you are going to get 50 Siemens centimeter square per mole. This is molar conductivity. This is how you need to solve the numerical. Children, let me take up one more numerical which is similar to that of a last numerical which you already solved. The resistance of a 0.5 normal electrolyte solution in a conductivity cell was found to be 25 ohms. Calculate the equivalent conductivity of solution if the electrodes in the cell are 1.6 centimeter apart and having an area 3.2 centimeter square. Children, look at here. The only difference between the last problem and this problem is the concentration is given in terms of normality, and they are asking to find out the equivalent conductivity instead of molar conductivity. Children, no need to change anything. You had to solve the same way how you have solved last problem. Let me take up this one, children. Given data. So concentration is given 0.5 normal. Resistance is given how much? 25 ohms. What else is given? L is given, is it not? How much? Is 1.6 centimeter. And area is given how much? 3.2 centimeter square. What are they asking? They are asking to find out equivalent conductivity, that is lambda E. Children, for this you need to know the value of conductivity. Children, again I will not write all that resistance is directly proportional to distance between two electrodes and inversely proportional to area and all. I'll directly write the formula. Children, K is equal to L upon A into R, because we have taken inverse of resistivity. Look at here, let me substitute the value here. L is equal to 1.6, area is equal to 3.2, resistance is equal to how much? It is 25 ohms. Children, if you simplify, you are going to get 0.02 Siemens per centimeter. You can calculate, you will get this value for conductivity. Once you find out the conductivity, it is easy for me to find out what is that? Equivalent conductivity with the same formula. What is that? Equivalent conductivity is lambda E. Look at here. Conductivity is given in terms of centimeter. That means you have K into 1000 upon what is that? C. K is how much? 0.02 into 1000 upon concentration how much here? Look at here. Concentration is equal to 0.5. Children, equivalent conductivity is equal to 40 Siemens centimeter square per mole. So this is what you are going to get if you simplify the expression. Children, let me take up the next numerical. The molar conductivities at infinite dilution for sodium acetate, hydrochloric acid and sodium chloride are 91, 425.9 and 126.4 Siemens centimeter square per mole respectively at 298 Kelvin. Find out limiting molar conductivity of acetic acid. Children, you have learnt about Coulombs law of independent migration of ions, is it not? What is the law states that? Children, limiting molar conductivity of a weak electrolyte can be expressed or represented as the sum of the individual contribution of all the cations and anions of a electrolyte. By using Coulombs law, you can easily solve the numerical. Children, let me solve the numerical. Now, what are they asking? Limiting molar conductivity of acetic acid, Ca3COOH, is it not? Now, how do I write that? As per Coulombs law, limiting molar conductivity of Ca3COO minus ion plus limiting molar conductivity of H plus ion, is it not? Now, look at here. Limiting molar conductivity of Ca3CO, Na, HCl and NaCl are given. By using that, you have to find out limiting molar conductivity of acetic acid is a weak electrolyte. Look at here, how do I write? Limiting molar conductivity of sodium acetate plus limiting molar conductivity of HCl minus limiting molar conductivity of sodium chloride. Children, look at here. Na I don't want, Cl I don't want, right? NaCl. So that is why minus NaCl. Hope you got it. What is left out? Ca3COH. Hope you understand that. Let me substitute the value. Look at here. For sodium acetate, it is a 91 plus for hydrochloric acid, it is a 425.9 minus for sodium chloride, it is 126. Children, if you simplify, you are going to get 390.5 Siemens centimeter square per mole. So this is what limiting molar conductivity of acetic acid. So children, it's very simple numerical. Hope you understand. Let me take up one more numerical on the same type. Children, let me go for one more numerical on Coulombs law of independent migration of ions. The molar conductivity at infinite dilution for sodium iodide, sodium acetate and magnesium acetate are 12.69, 9.10, 18.78 Siemens meter square per mole respectively at 25 degrees Celsius. Calculate limiting molar conductivity of magnesium iodide. Children, let me solve this problem. Limiting molar conductivity of Mg(I2) is equal to, look at here, limiting molar conductivity of Mg2 plus limiting molar conductivity of I minus. This you need to split. Now, how do I write? Look at here. Limiting molar conductivity of Mg(I2) is equal to limiting molar conductivity of Ca3COO minus twice Mg2 plus limiting molar conductivity of NaI. Look at here, I need 2. Alright, 2 here minus limiting molar conductivity of Ca3COO minus Na plus. This I need 2 because I need to remove twice of acetate ions here. Now look at here. So this is given how much? It is 18.78. Is it not? Plus 2 into NaI, how much? It is 12.69 69 minus 2 into 9.10. Children, if you simplify, you are going to get 25.6 Siemens meter square per mole. This is what? Limiting molar conductivity of MgI2. Children, let me take up next numerical for you, which appears to be very difficult, but it is easy if you understand the numerical in a better manner. Resistance of a conductivity cell filled with 0.1 molar KCl solution is 100 ohms. If the resistance of the same solution when filled with 0.02 molar solution is 520 ohms, calculate conductivity and molar conductivity of 0.02 molar KCl solution. Given conductivity of 0.1 molar KCl solution is equal to 1.29 into 10 to the power of minus 2 Siemens per centimeter. Children, in this case, we need to solve the numerical in 3 different parts. First, you need to find out the cell constant by using the data for 0.1 molar KCl solution, and then conductivity of 0.02 molar KCl solution. At the end, the third part is for finding the molar conductivity of 0.02 molar KCl solution. Let me solve this numerical for you. Solution. Children, the first part I said that I am going to find out cell constant, and let me write down the data. R is how much? Is for 100 ohms. So this is for what? This is for 0.1 molar KCl, that you need to remember, right? And then what else is given? Conductivity is given. Conductivity is equal to 1.29 into 10 to the power of minus 2 Siemens per centimeter. So what you are supposed to find out? Cell constant. Supposed to find out the cell constant. Children, you know cell constant is equal to conductivity upon conductance. Is it not? Conductivity upon conductance. Now what do I do? Conductance is nothing but inverse of resistance. Conductance is equal to inverse of resistance. Is it not? Now what do I do? 1 by R, R will go to numerator. The cell constant is equal to K into R, resistance. K is how much here? 1.29 into 10 to the power of minus 2 into resistance is equal to how much here? 100. So I'll cancel these two. That's equal to 1.29 centimeter per centimeter rather, which is equal to cell constant. Cell constant. Children, once you find out the cell constant, now I'll go for the second part, that is finding the conductivity. That is K of what? 0.02 molar KCl solution. Children, look at here, what is given here? R is given 520 ohms for 0.02 molar solution. Now cell constant, you know that cell constant is equal to how much? Just now you found out, that is 1.29 per centimeter. Now what you are supposed to find out? K, conductivity. Children, you know the expression. What is that? Just now you learnt. Cell constant is equal to conductivity upon conductance. Now what do? Now I need to find out conductivity. K is equal to cell constant into conductance. Is it not? Conductance. Children, conductance is what? Inverse of resistance. And what do? Cell constant upon, I'll write as 1 by R. So R, resistance. Now cell constant is how much here? 1.29 per centimeter. Upon resistance is how much here? 520 ohms. Children, if you simplify, you are going to get 0.00248 Siemens per centimeter, or I can write 2.48 into 10 to the power of minus 3 Siemens per centimeter. So this is what? K for you. Hope you got it. Once you find out the conductivity, now I'll go for what is the third part. What is that? Finding the molar conductivity of 0.02 molar KCl solution. Children, you know, molar conductivity is equal to K into 1000 upon C. K is how much here? 2.48 into 10 to the power of minus 3 into 1000 upon C is how much here? 0.02. Children, if we simplify, lambda m is equal to 124 Siemens centimeter square per mole. So this is how you need to solve the numerical.